Hey guys, everything new under the sun. Alright, what you're looking at here is a finally completed MAKITA battery bank or backup generator that you can use for all sorts of purposes. And my original purpose was to run an Airstream camper off the power of MAKITA batteries, and I can kind of do that. We're going to get into that, but this project took me a lot of time. It took a lot of components, and the original reason for creating it was that I had MAKITA batteries. I had 4 amp hour MAKITA batteries, and I wanted a system like the Dewalt Power Bank, where you could plug in a bunch of Dewalt batteries, as an example, and use an inverter to power things. Now, this particular one doesn't have an inverter immediately, but I can plug an inverter into it, and basically it down converts an 18-volt battery into a 12-volt battery. So without further ado, I'm going to show you the features, and then we're going to go through a walkthrough with a voiceover of how I built this and what I got out of it in the end. So let's take a closer look. So of course we've got the MAKITA impact driver. Don't have the battery on it because the battery is in here. Now, I originally built this unit to take up to 3 batteries, MAKITA batteries. We're going to take a look at the inside, but initially on the outside, the first thing we have is a voltmeter to see the voltage. Now, of course, this is running an 18-volt MAKITA battery, but you can see it shows 13.4 volts. I'll show you how we got that. The other thing is we have a nice 12-volt socket, so we can plug little 150-watt inverters in here, little 12-volt converters to inverters to 120-volt power, so we can use that. This particular unit will provide up to 20 amps, 25 amps, which is basically the same as what a car would provide in terms of amperage. So you can go up to maybe 200 watts worth of inverter plugging into there. So that's a 12-volt socket. Over here I've got a USB charger, and this works. So I've got my iPad here, and I'll plug this in. You can see the iPad will light up, and it says 47% charged. So that's great. That works 100%. And this is a 2.1 amp on the bottom and a 1 amp charger, USB charger on the top. So perfect little emergency thing for charging your cell phone. Let's get that out of the way. The other thing is that we have an on-off switch, which I have not wired up yet, to power up all these so that they're not draining power from the MAKITA battery all the time. And then I have some big clamps here, which I could stick some big wires to if I want to, then plug it in line with the Airstream existing battery bank. And these just come off, and you can put clamps on there or whatever you want, and basically power any 12-volt equipment with 20 amps available at these posts for usage. Now, the amperage isn't huge, but then you don't want to burn out your MAKITA battery. It's only, the more amperage you drain at the same time, the faster you're going to discharge your battery. So this is kind of a small emergency kit. Now, the other thing that I did make this for, it was a bit of an emergency kit. So one thing I got off eBay was this particular unit here. It's a little flashlight, and this plug slides off, and it actually coils out. And then if we plug this into the 12-volt socket, you can see that it indeed lights up, and so we've got our 12-volt power. And this is actually magnetized, so you can stick it on a surface and have it lighting up a work area in an emergency, and so it works very well. So let's go ahead on the inside, and I'll explain some of the features, and we'll talk about the actual build of this particular unit. Alright, opening up the case, it reveals the internals, and for this one, let me just set it up there, make sure we're centered here. Now, I'm going to go into the build of it, but what I've done is I have a MAKITA battery here. I also have another MAKITA port available for a parallel, basically 8 amp hours of MAKITA battery. I haven't got my case on it yet, but it just slides in like this. And you can see the back little voltage controller, regulator, lights up. Let's plug this back into here. So I've got the MAKITA battery. I've got 2 that I can put in parallel right here for 8 amp hours of total power, and I could wire in a third if I wanted to. And then what I've got it going to is this little voltage converter here, and this converts 18 volts down to the 13.4 that we saw on the front of it. I've just got it screwed down to a board here. I had some bigger plans for this. I was going to put also in a, let's see, a charger here. This is a solar power charger. I was going to use this to actually convert power and push power back into the Makita battery so I could actually recharge this with solar power. But I think I can do it with my larger solar power setup anyways, and I can charge my Makita batteries. No problem there off my 600 watt pure sine wave inverter. So I've got a couple of extra cables in here that I can put on my posts on the outside to plug it directly into the rest of the power system. Remember, this could be used to power or provide a parallel capacity to my existing Airstream battery bank. I think that was it in terms of emergency setup. I did have some other fuses and things that I never did end up putting into it, just to prevent anything more than 20 amps, because then I would burn out my low voltage converter there. I also have this little guy, which is another voltage converter, and I was going to use this to increase the voltage so that I could actually go back and charge the Makita batteries, but that's a part of the project that I did not get to. So with that said, I'm going to go to the actual build video, and I'll do a voiceover of the build, and we can see how it goes. And then I'll provide my ending comments about how I think this build went at the end. So I'll provide some extra comments and kind of tell you the background of what I was attempting to do. So I had several Makita batteries, a 2 amp hour and 2 4 amp hours, and I was trying to duplicate the Dewalt power bank like I was suggesting. And so what I did was I started pulling components off eBay that I thought would be able to would go along with this, including voltmeter, 12-volt socket, and some voltage converters. To get started, I started kind of writing down, trying to visualize, give you a visual of the layout, the flow of this power system, from the batteries to the voltage converter to a bus bar, which didn't work out, and I'll explain that later, to some posts so I could do some external charging or connect it in parallel with another battery bank, all the way to some solar recharging that I was hoping then to push power back into the Makita batteries if I had a solar panel to charge it at the same time. So it would become effectively its own solar generator, all based off stock Makita batteries. Makita batteries are very good. And when you're on vacation or in an emergency situation, you know, your Makita batteries have a good store of power. So how do you make use of that? And most of the camper slash emergency things are based on 12-volt systems. Lights, for example. Car inverters. You can get cheap car inverters based off 12 volts. So what you have to do is down convert 18-volt Makita to 12 volts. So I got a couple of cheap Makita adapters. You can see they're kind of the blue. They blend in with the top of the pool table there. I know I get comments about a horrible use of a pool table, but hey, it's a great surface. So first thing I was trying to do was desolder the wires from these boards, and I could not get them off. I ended up cutting apart the plastic on either side, and then crimping on some clips to go right onto those yellow pieces there, which are actually the blade inserts that go into the battery to connect it to the main metal pieces. I didn't need the circuit boards anyways. I'm not planning to use the USB that was on those little battery clips for the USB chargers there. It was a bit of a mess, and I didn't end up completing this project in a 100% manner. I never did get around to putting or installing the charging component of it. And maybe I'll do that in a future video. But the main thing was just I was running at a time. I wanted to get this video done. So the main thing was get the 18-volt Makita batteries working, use my voltage regulator, make sure it was working as expected, and get that at least wired up. So what I ended up doing, I was going to wire it up for 3 parallel Makita batteries. I ended up going with just 2, just to simplify the project. And so the 2 yellow pieces in the center, those are the Makita battery clips. Those are wired in parallel. So you still have 18 volts at the end and 8 amps and 8 amp hours of capability or storage capacity when both my 4 amp hour batteries are plugged in. 8 amp hours total. Lots of crimping and such, and I use a lot of butt connectors and that sort of thing. It's a fairly straightforward project. I also got the 12 volt socket adapters and voltage indicators that you see there off eBay. There's a little switch which I didn't even wire in, so you can leave the batteries in there and turn the switch off so it's not consuming energy. And then here I'm drilling the holes for the battery posts so that I can plug in this 12 volt system in parallel with my main battery bank and use it as extra capacity, or use it to charge up the battery if it's dead to support it, basically. Again, in an emergency, or powering something larger. Maybe you're even trying to power some larger piece of equipment, and you need the big posts for that. Now, this will only handle a total throughput of about 20 amps, and that's a limitation of the voltage regulator that I could find on eBay. But that's plenty for providing power to cooler, for example, and a small car inverter, etc. So that's kind of the build and the pieces that went together into this project, and I'll give my final comments after this. So for my final thoughts, of course, the conclusion is that I didn't 100% complete this project as I would have liked to. That being said, it is functional. It does not charge, and that's a second piece that I'd like to get to. It's just a time issue, and I'm not even sure if it would work 100%. But in the end, what I have is something that I can plug my Makita batteries into. It was a great little project to try out. Overall, in parts, I think this cost me about $200 in parts. By the time I got the wires, the big Makita case, which is $30 in and of itself, the posts, and some of the pieces, the voltage regulators, the Makita battery clips so that I could pull them apart just to use those for connecting to the batteries. Yeah, all in all, it was about $200. And the flashlight, and if you want to add a little inverter to it, I do have a little 12 volt socket inverter in my car that I can use to make this more useful. So this would be a great emergency kit if you just want to throw it in the back of your car and you want to be able to charge some cell phones, an iPad. It would be even better if I got the solar plugged in, so you could have a small, maybe 40 watt panel plugged into it, charging the Makita batteries all the time. But like I say, it makes a great little emergency thing if I need a light, an emergency situation, and when the power goes out in your house, for example, you're not going to be pulling out your Makita power tools and building a porch. So why not use that energy for some other purpose? So in terms of that, overall it went okay. It didn't have all the features that I would like I say, the solar charging. But it did complete the original purpose, which was to make a power bank that I could use that was kind of like the Dewalt Power Bank. Now, the Dewalt Power Bank has an 1800 watt inverter. I can't beat that. I don't have enough money to get an inverter like that or to get the equipment to be able to draw that much amperage off the Makita batteries. I would need a big voltage converter, and I just didn't see that on eBay. That being said, for emergency, for smaller items, for charging of smaller items, I think I can plug in up to a 200 watt inverter, and that should work just fine from the Makita batteries. And the fact that I can have two Makita batteries in parallel means you can do quite a lot if you really want to. And if I don't want to take my whole solar power system to a campground, well, this is an easy way, a little box I can just kind of pile all my equipment into, take it to a campsite with a tent, and be able to charge some small electronics. And it's an all-in-one unit, and of course it also has the camp LED flashlight. So this was a demonstration of the charging the iPad. So yeah, it worked great. I've got the 2 amp charger and the 1 amp charger on that USB plug, and then of course the on-off switch if I want to. So overall, it was a fun project. It didn't 100% do what I wanted to. Things always change once you actually start building these sorts. But I just want to make a battery bank out of my Makita batteries, and I think I've completed that. So I hope you guys like it. If you want, let me know if you want more videos about this later, and maybe I'll do a follow-up video, maybe getting the solar power going or something. That's something I'll look into. But thanks for watching, and share it around if you like it, and leave a comment. Tell me what you think I should have done or should have done differently or whatever. And that'd be great. Thanks a lot, and we'll see you guys in the next video.